Hello and welcome to another tutorial. I'm going to continue our discussion on the native image build output options, and we saw that there are two types of options, and you can look at the very comprehensive list with the -- expert options all. And one of the categories is the build output options, and again the two types of options are either -h colon or -r colon. As I mentioned in the future lectures, I will go into more details of these if any of the options are very important. For example, we saw that the build output options, they are -h colon, and all of them are boolean, and you enable or disable them with plus or minus. Plus means enable them, and then minus means disable them or set them to false. And then we also look at the default values, like pretty much everything by default is enabled except for this one, build output prefix. This we saw that it prefixes the output name of the native binary and also the PID or the process ID that was run. PID image name, and it's disabled because we don't care that much about it. And I mentioned also about this pipelining on the bash terminal, and we saw that there are two types of pipelining. One is this operator, which is called pipeline. The other one is the greater than symbol or the arrow operator, which redirects the output of the application to basically a file, right? This pipeline operator redirects the output of the application to another application. That's how you can change them, right? And if you just want to look at all the expert options all and then filter only the ones that have this build output string in them, you can pipeline the output of this command, right? Native image -- expert options all, and then pipeline the output and use the grep binary. Like, it's an application that its job is to filter out all the lines of a text or whatever is the output of another application is using the string that you provide. So it only filters out, and the fish terminal is very intelligent. It shows you this string in a red, which is very easy to see what's going on. So if I execute this command and say pipeline grep build output, it only filters out and shows me the outputs, that the options that have this build output string in them: breakdowns, colorful, GC warnings, links, prefix, progress, use new style. All right. And now I want to basically show you the same pipelining with a application. We write a Java application, and then we compile it to native executable binary, and then you can, for example, feed it inputs if your application needs some input using this pipelining basically operator in terminal. So let's head to our Eclipse. Now previously I had this test2 and test3 directories, and I actually added them to my class path. So let me open up a terminal at the root of my Java project. If you look at my class path environment variable, which my terminal understands that because I defined this in my bash RC, so that every terminal session that I open, they are aware of this class path, and test3, test, and test2, right? So any Java class, Java source file that I put on any of these, and I just run Java C on it, I don't need to specify the class path, because if you don't explicitly provide the -cp or -- class path, then the Java C and also the JVM, they just search for the class path environment variable. So what I'm going to do, let's delete these previous artifacts that we created. I'm going to create a new, or maybe let's just copy and paste this Java file. Let's paste this. Let's call this command line or terminal pipelining. Terminal pipelining. So obviously the name of the class should be the same as the source file. If it's a public class, terminal pipelining. All right, what we are going to do, we are going to ask the user to let me also clean up everything here. Now we saw that the command line arguments actually get passed as this string array, but we don't need to really do that, right? The other way of getting information, so one way is to use the string args, right? And these are passed when you launch your application. But besides that, you can also use the standard input. So the way we do it, we use the scanner class. A scanner is new scanner, And then here you want to specify an input stream, and for that you provide a standard input to your JVM. So system, remember when we in the Java source file, when we want to talk about JVM, is the system class. Dot in is a input stream, which is an abstract class, right? A static, final, and input stream is abstract class, and the standard input stream, which means input to your JVM. And now you can see what's going to happen, right? I can have some other application that outputs some text, and then when I pipeline it to the input to my JVM, so system.in means something that feeds information or a byte array, right, or char array to my JVM, and the JVM can read them one byte by byte, right? Obviously that's an inefficient way. That's why we have a scanner that provides buffering. So the standard input stream, this stream is already open. We know that as soon as you run your Java application, there is a dedicated stream to it. And then while, for example, we know that a scanner follows the basically a iterator pattern. So it has next, and has next line, etc. I want to has next goes through the output, or basically whatever is fed to the scanner word by word, right? Returns true if this scanner has another token. Token is just a word, means some non-white space characters. It reads them until it hits the first white space character, right? So when has next, we're going to do a sysout or system out. Now we're using the standard output of our JVM, which is by default is hooked to the terminal, whatever shell or command prompt or terminal you're running your Java application in it, right? So we're using the the input stream, a standard input to our JVM, and we're using the standard output of our JVM to print line and a scanner next, right? Scanner dot next. I think this is going to work. I believe a scanner has a next method. Let's just check on that. Yes. So it returns a string. So it reads next token. Token means basically it starts from some point in your byte stream or character stream. Starts from a character that is not a white space and reads until it hits the first first white space, right? So next reads word by word, and obviously a scanner is it, or in general iterables, something like this. These are one-time use. So once you, because these are kind of like the iterator pattern, right? So once you consume the iterator, you cannot reuse it again. So once you hit the next, you kind of need to create a new scanner, right? So so what we do, obviously we first need to compile this. And note that I'm not even in this test directory in my terminal. I'm inside the Java native image, which is the project, but doesn't matter. I have my class path ready, right? It's set up. It's already inside. So the Java C already is aware of this basically test directory. So I just tell it terminal pipelining.java. Now it's not going to obviously find it, because when you use Java C, you kind of need to give it the full path to the file. Test terminal pipelining. All right, and this class, note that I did not basically import the. So basically, we already had imported the scanner, right? So if we didn't import the scanner, because a scanner is in the Java util, Java.util, and we know that Java util by default is not imported, right? So once you run this without importing that, it tells you a error saying that I don't know this type, this scanner. So that's why you kind of need to say that import java.util.scanner. Now import, remember, import is just a basically another way, an alternative way of just using the fully qualified name. I could just use the fully qualified name and I don't need any import statement, but usually fully qualified name makes your code a little bit ugly, so we prefer to do the import the type or the class itself, and then interesting thing, if you look at the bytecode, there is no import statement. Import statement has absolutely no effect on your bytecode, on your class file, because the compiler actually replaces this scanner, this line, with the fully qualified name. And I will show you. So import statements have no effect. Now this is different from C++ application. Whenever you include another header file in your C++ source file, the preprocessor actually copies the entire content of that header file into your CPP, and the compiler goes through them. So if you include IOStream in many different CPP files, the compiler has to go through them and compile them again. And that could be time consuming. That's why there are other things like compiled headers. So headers that are already compiled to binaries, and then so the compiler doesn't have to do that. Usually, I mean, compilers are pretty fast these days and the computers are fast. So people don't really notice the fact that if you include IOStream, which is a very huge header file, right? If you include, for example, IOStream in many different CPP files, then the compiler has to compile it over and over again. In Java, it's not like that. In Java, the import statement doesn't do anything. It really doesn't change the class file at all. It has zero effect, because at the compile time, the compiler removes this line. It's like this line doesn't exist, and it rewrites the type with the fully qualified name. And at runtime, the JVM looks at the type, which is the fully qualified name, and it starts from all and searches in all the directories that are on the class path and sees if it can find a type with that fully qualified name. And as I mentioned in my past lectures, fully qualified name means JVM expects a directory hierarchy. So from the class path, when JVM sees Java util scanner, it searches in all the directories that are on the class path to see if there is a directory called Java. And then if there is a directory, it searches inside that to see if there is a directory called util. If there is a directory called util, then it searches inside that to see if there is a class file called scanner.class. If it cannot find it, it says a class not found error or class def error or something like that. Again, I repeat these concepts because these are very important, and these happen behind the scenes, and something that most Java developers, people who don't have much experience with what happens behind the scenes, they might not notice that these are very important concepts. Again, so to summarize, in Java, import statements have absolutely no effect on your class file. So let's rewrite these, and then let's open this class file with a class file viewer. I don't want to decompile it. And as you can see, there is absolutely no mention of import statement, right? The class has a fully qualified name. Right now, I didn't put it in a, I didn't put it in a package. So it's just the name of the class. And then the compiler provided a default no argument constructor, which is public, which just calls the constructor as the superclass. And then we have a main method. And as you can see, we are creating a scanner, and the scanner in the source code was replaced with a fully qualified name. So this is the effect of the import statement. So you can either directly in your source file type Java util scanner, or you can just type a type the import statement once, and then use a scanner, this word scanner, multiple times, and then the compiler replaces all those words with the Java util scanner. So that's just the meaning of the import statement. All right, so we compiled this, and obviously we can also run this. Again, I'm not going to explicitly specify the class path here, because this directory test where my class file is already on my environment variable class path. So I'm just going to say that terminal pipelining. Okay, class not found exception. So let's see. Oh, okay. So the reason is that now by default, so I think what we should do, -cp, let's try to give the class path. So so Java -cp from wherever we are, go into test, and then terminal pipeline. Oh, okay. So I was typing the name wrong. So Java terminal, let's make sure we don't lining. All right, now it works fine. We don't specify the class path, but But then JVM searches also in the directories if the class path environment variable is defined. Now it's waiting for us to type something to the console. So hello, how are you doing? And then we hit enter, right? So the scanner system.in scanner waits until you hit the enter. Whenever you hit enter, it means you finished up, and then now it prints them to the console. It is still waiting for us. So more text, hit enter, more text, right? So basically when you hook this up to the standard input of your console, now you can add text here, right? And then if we print enter, now it's waiting indefinitely, right? So this application doesn't terminate because it's hooked directly to the standard input, right? So I'm going to hit Control C to give the terminal or the operating system a signal that, hey, I want to terminate this application. So Control C is a signal to your operating system that to kill this process, right? So that's has next. What we're going to do in order to not go into an indefinite loop, we're going to say has next line. So line, then a scanner searches for \n, right? And then we're going to print line by line, next line. So this way we should be fine. So let's compile, and then let's run. Now it's waiting for us. Hello, how are you? And then as soon as we hit enter, it's still the same thing. Now it's print the entire line instead of printing word by word, right? So again, Command C, we terminate this. So what we're going to do first, we're going to put something to the console. So we're going to say that sysout enter, for example, enter your name, or your enter your first name, and then let's see, and let's use print, so we don't want to go to the next line. And then after that we create a scanner, and then we're going to say that a string name is scanner.next. So this scanner is hooked up to the system in, so we can call it anytime we want and try to read something. So right now we're saying next. Next means next a string, right? Which comes from the terminal itself. And then we're going to sysout your name is %s dot formatted and the name. All right. So let's go ahead. We're going to compile and then run. And enter your first name, let's say Sam, and then your name is Sam, right? So it's working properly, and then the application terminates. All right. Now the thing here is that what if I don't want to? What if I want to automate this process? Let's say I want to have some sort of I have a Java application. I want to test it on terminal, but I don't each time I don't want to basically type the inputs manually. Let's say my application expects lots of inputs, right? So we can use this pipelining. So let's say if I use echo Sam, it's just, we know that the output of this command, remember echo is also an application, and you feed it something, it just prints it to the terminal, right? Now I can say echo Sam and then pipe it to something, and that something is just my Java application, terminal pipelining, and it says enter your first name, but it doesn't wait for you, because when you pipeline, the output of this application goes to your is redirected to the input of your second application, and it inputs it to the redirects it to the input of the JVM, and the input of our JVM is hooked up to our scanner, which is expecting to read a string and then prints it to the console, right? So this way it actually didn't wait for us to print something, because the system in is now has some character array that is being fed to it using this pipeline operator, right? So it just says that your name is Sam, and then it didn't wait for us to hit enter, for example, here. Now we could basically say \n here. So if we go ahead and compile again and then run, and now it doesn't wait for us to type anything, it just immediately reads whatever a stream that comes from the pipeline operator from the previous application. And obviously, because we are just reading from a scanner, we are reading next word or next token. If I have a 2 words here, it only reads the first word. So what we can do, we can read it, and then so let's also say enter your last name. So this name becomes first name, and then we're going to say that last name. Again, we use the scanner, and then your name is %s, first name, and then last name. And then what we're going to do, we're going to compile and then run. And now you see it doesn't wait for you to enter anything, because it has already an character stream in the pipelining. So the input of the JVM already is being fed some characters. And then it says your name is Sam Bob, right? First name, last name. So it reads the output of this, and then basically works fine. Now this is, now we're running on JVM to test our application, but now I can also basically compile it, right? Native image, and then say -cp. I'm going to feed it just the class path, right? Or maybe let's go inside the test. By the way, in the fish terminal, if you just say to execute a directory, it is, remember in the past when I reviewed the concept of terminal, I said that directories have executable permissions. So if I just try to execute a directory, the fish terminal is very intelligent to realize that, okay, this is a directory, so it just goes into it. Now if I exit the fish terminal, the terminal that by default comes with the macOS is not that intelligent. If I say test, it says that test is it's not executable, but the fish terminal is very intelligent. It knows that when you are executing a directory, it means you want to jump into it. So actually, oh, okay, so where are we? Okay, so this test doesn't exist, so let's go to this directory. So I can use cd, I can just type the name, and the terminal, the fish shell is very intelligent to know that you want to cd or change directory into it. So that's a shortcut in fish shell, is instead of using the cd command, just try to execute that directory, / the name of the directory, and it's going to work fine. So test, note that this doesn't work. You have to use, in the macOS or Linux, you have to use dot and the name of the application. In this case, it's a directory, right? And now I jump into test, and now I call my native image, and then -cp. Let's just use here, we don't need to use the class path, and then terminal pipelining, and then terminal _pipelining. So we are compiling this class file. The output of the executable file, the name is terminal pipelining. It's going to quickly compile. It's going to be pretty fast. Probably takes 1 minute or less than 1 minute. All of my CPU cores are fully maxed out, because by default the native image uses all the threads available on your CPU, so that it reduces the compilation time. So what I want to show you is that not only we can pipeline to the JVM, which runs our class file application, we can also pipeline to the native executable binary that comes from compiling our Java application. So if I say terminal pipelining, this is my Java application. Enter your first name, Sam. Enter your last name, Bob. Sam Bob, right? Now we can say echo Sam Bob, but instead of running the Java, which is our JVM, we're just going to run our Java application. which was compiled to native executable binary. And you see that first the output streams are printed, and then it reads the input to our the input stream that comes to the application, and then it prints the correct output. So pipelining is okay if you want to, for example, basically automatically provide inputs to some application. It could be a Java application running on top of JVM. It could be a Java application that has been executed to native executable binary. So what I'm saying is that pipelining is not a feature of the Java, right? It's a feature of the operating system and the terminal, the shell. Now, another feature, right now we're using the command line or terminal pipelining. But what I can do, I can create a text file. Let's call this input.txt, and then I am going to put Sam and Bob here, for example. All right. Now let's see what happens here. If I want to print the the content of a text file to the terminal, I can use the cat command, cat input.txt. And now you see that where I'm going with this, instead of using the echo. So remember, if you say echo the name of the file, echo assumes that everything is a string and you just want to print it to the terminal, which is not correct, right? What I want is to basically read the input of this text file, and cat reads the input of a text file and then also prints it to the console. So what I can do, I can say cat input.txt, but instead of printing to the console, pipeline it or feed it to another application, which is my terminal pipelining. So it reads the input, and the input is fed to my application. So it says your name is Samba, right? So that's another way. So we've also seen that we can redirect the output of an application to a file, right? So I can say execute this, but then redirect the output to terminal.txt, right? So so let's see, Sam, Bob, and then it finishes. So it waits for your input in the terminal, but then the output of this application, whatever you use to, let's say, whatever you feed to the system.out, it's not going. So if you look at the terminal.txt, it says enter your first name, enter your last name, and then we provided this input in terminal, and then the output of the application again was redirected to the file instead of the terminal, which is the standard output. So I hope you enjoyed this lecture and now have a very solid understanding of this redirection and pipelining. Sometimes, especially when you're running an application in the background, what you want to do, you want to redirect the output to a text file or something, to a log file, so that you can track those applications in the background to see what's going on with them, right? So please stay tuned, and I'll see you in the next one.